What's good, guys? Welcome back to lesson 4.1. It's an easy lesson. Miss Leg's gonna breeze through it. Let's go. Ka-chow.
Okay, it's a proud dad over there. Okay, I forgot to record my first little spiel. But what we were just talking about was we're going to do a lesson where we graph more than one line, specifically two lines, on the same coordinate plane. If they intersect, there is
no solution.
A solution.
There is a solution.
If they
It would be, how many solutions would it have?
One.
Is it possible for them to intersect twice?
Yes.
No, if it's a linear equation, it stays on that same line the whole time. The slope stays the slope. They can't like wiggle and
Well, if they're curved,
meet. No, not linear equations. So that would be one solution, which would be the point of intersection, which is a coordinate pair. Then we also talked about two lines that could be on the same plane that never intersect. We call them parallel lines. How many solutions do they have?
None.
Zero.
None.
No solution.
They have no solution. Then here we go. We then start talking about that third option where you try to graph two lines and something weird happens. We end up with so many solutions that we can't even count them. How is that possible that there are so many solutions that you can't?
The lines are on top of each
The lines are on top of each other. Basically, it's the exact same linear equation, but sometimes they're in disguise. Maybe they're not in slope-intercept form. Ooh, and they don't look like the same linear equation. I kind of like this. I need a megaphone for this class. So you might have to decode some equations to see, are these lines parallel? Are these lines the same? We need to kind of decode them and rearrange them to see. So that's what we're learning about today, just those three things.
What's the answer for that last one?
Oh, infinitely many solutions. If they're the exact same line, then every single point on that line, on those lines, is a solution. Every single point, even the itty bitty decimal points.
You said infinitely many.
Infinitely many solutions. So it's not just many solutions, it's every single possible solution that could ever solution. Okay, that's why they say infinitely, because it can't be contained by a closed set of numbers. It just goes on and on forever, just like the lines. Okay, I'm gonna show two videos. I might pause them just to go over a few quick things, but you will definitely get a lot out of these, I promise.
Let's find the solution to this system of equations by graphing. In order to use the graphing method to solve this system of equations, we need to start by rewriting each equation in a way that we can easily graph it. In other words, we need to write each equation in slope-intercept form, or we need to solve each equation for y. When we solve our first equation for y, we get that y equals 2x minus 2. When we solve our second equation, we get y equals negative 2x plus 6.
Okay, I'm gonna pause her because why the heck would you speed through such a complicated part and just expect that we're supposed to know what you just did? She just took that and was like, yeah, I'm gonna put that in a slope intercept form. Ka-chow, right? Is that what you say?
No, it's ka-chow.
I did say
You said
ka-chow.
ka-chow.
Well, I was, okay, sorry. Hey, that kind of looks like me. Okay, so she took this wacky form and then changed it into slope-intercept form. But that's good. She didn't just do that in her head. She had that memorized. She probably practiced. If we were to put this into slope-intercept form, we would take certain steps. No, you may not use the bathroom.
It's not working out.
What is it?
It's like those problems that we did where with the signs of equations and how we rearrange them.
Yeah. Okay, good. So I'm gonna go through the steps of how to get from here to here. We have done it before, but just a refresher. I'm gonna rewrite what she has up here. 2x minus y equals 2, and then she just automatically spits out slope-intercept form, and I don't like that she skipped it, so I'm gonna slowly take this apart to solve for y. What's the first thing we do? What? Nope. Yes. Nope. There are no like terms here. Yeah.
Make the two variables the same.
Make the two variables the same. What, you want me to just like erase the y and make it an x? That'd be cute. No, Carmine, what?
Subtract
Subtract what?
2x
Yes. Subtract 2x from both sides. Guys, all I'm trying to do is get y by itself. How do you do that? You say goodbye to anything else that's on its side. You say, peace out, this is gone now, but look what I have. I have a negative y, which we'll take care of in a second, equals these two terms. I have a positive 2 and a negative 2x. Does it matter which one goes first?
Nope.
No. So which one do I want to make go first?
2.
The
2x.
x term, right? Because that will make it with where I have my slope first, negative 2x, and then my y-intercept, which is positive 2. If your 2 is positive, then go ahead and put a plus sign. A plus sign is a positive sign. So we can kind of make that positive sign appear. It's still not in that slope-intercept form. It looks different. What's the problem?
Negative
The negative. Now what do we do?
Minus, yeah. I mean, the minus.
Minus the minus.
Subtract.
Divide by what?
I think somebody said it.
Subtract.
Nope.
Divide by negative.
Divide by a negative. Because if y is being multiplied by negative, and if this helps you, keep in mind that when you don't have a coefficient, aka a number, next to your variable, if you want, go ahead and poof, make a 1 appear, if that helps you. Then you can see, oh, y is being multiplied by negative 1. I'm going to do the opposite by dividing it by negative 1. A negative 1 divided by a negative 1 is what? Positive 1. And that's how we cancel out a negative. And you might say, but then don't you still have the 1? Sure. 1y is what?
Just one.
Just y. Because I'm gonna have y once.
Don't you do it on the other side?
Absolutely. So not only do I do it on the other side, but I do it to every term on the other side. When your terms are separated by either addition or subtraction, and you're dividing, you have to do it to every term on the other side. So divide by a negative 1 over here, and all that does is it flips the sign. This negative 2x becomes a positive 2x. This positive 2 becomes a negative 2. Because when you're dividing by a negative, it changes the sign, right? Positive over positive becomes, negative over negative becomes positive. Positive over negative becomes negative. Now we see how she magically changed this one into slope-intercept form. And this one was a little bit easier because the y you didn't have to take care of the negative. All she did was subtract 2x from both sides, and then she got y equals negative 2x plus, and she's about to write a 6 there. Totally get this? Okay, because this isn't the new concept of the lesson. This is something that we have been working with, rearranging and solving for y. Just like those weird test questions that you hated when it would give you like the simple interest formula and it would say solve for r. Where it would give you a formula that you've never heard of and be like solve for t in terms of r or whatever it was. It's simply rearranging equations, keeping everything true, and always doing the same thing to both sides, solving for a specific variable, in this case, y. Just let's take a moment to appreciate that we're not dealing with function of x, because that would get super ugly. Okay.
X. Great. We've solved each equation for y. We're ready to graph. So in our second step, we want to graph each one of our equations on a coordinate plane. So we'll draw our coordinate plane and label our axes. And then we can graph each one of our lines. So let's start by looking at y equals 2x minus 2. Here, we have a y-intercept of negative 2, so we plot that point. Then we have a slope of 2, or 2 over 1. So we use that slope to find our next point. We start at our y-intercept, and we move up 2 and right 1. Then up 2 and right 1. Then we can draw our line. Perfect. Now let's look at our other equation. Y equals negative 2x plus 6. Here, 6 is our y-intercept, so we put a point at 6. Now we have a slope of -2, or -2/1. So we start at our y-intercept, and we move down 2 and right 1. Then down 2 and right 1. Then we draw our line. Now we've graphed both of our equations.
Why do you think she kept going and making more points on that line when technically you only need 2 points to form a line? Faith? Yes, very, very well
Where did she
said.
put them?
The more information she puts on that graph, the more points she plots using that slope, the clearer that intersection is going to be when those lines cross. If she didn't put that extra point there, the lines would cross, but it would be kind of hard to tell what point it was at. So whenever you are graphing freehand, go ahead and we'll do this in the examples, but we're gonna keep using our slope to just keep getting points like all the way across, and then we can draw a line through them. And the beautiful part is, when you do your homeworks and your tests and things like that, it's all digital, so you can still just graph your 2 points and move on with your life.
On a coordinate plane. We're ready to find our solution. Using the graph, we want to find the intersection of our 2 lines. So here, where do our 2 lines intersect? At this point, right here. The point 2, 2. This is the intersection of our 2 lines. That means it's the solution of our equations. The solution to this system of equations is the ordered pair 2, 2. It's the point on the graph where the 2 lines intersect. But just to be sure that this is the solution, let's check our answer. So in step number 4, we'll check our answer by taking our solution 2, 2 and plugging it in for x and y in each of our original equations, then seeing if it makes a true statement. So our first equation was 2x minus y equals 2. We're plugging in the ordered pair 2, 2. We want to see if that makes a true statement. So we have 4 minus 2, and does that equal 2? Yes, it does. 4 minus 2 is 2, and 2 equals 2. So we have a true statement in our first equation. Now, let's check our second equation. Our second equation was 2x plus y equals 6. Plugging in our ordered pair, we have 2 times 2 plus 2. Does that equal 6? 2 times 2 is 4. And 4 plus 2 is 6. Another true statement. So when we plugged in our solution, 2, 2, into each of our original equations, we got a true statement in both cases. That means that we have the solution to the system of equations. The solution is 2, 2. And since we have one solution, the system is considered consistent and independent.
So she just threw out 2 crazy vocabulary words there. What were the 2 last words she just said?
Consistent and independent.
Very good. When you have a system that creates one solution, it's called consistent and independent. Everybody say consistent, and independent. Okay, good. So was that video helpful?
Yes.
Okay, we have one more.
So what is the definition of each of those words?
So all you have to know for now is that when your system creates one solution, it's consistent and independent. Because
the
you-
definition of the word.
Well, I mean, there are certain definitions of the words, but those words apply to, for example, you might have a homework or test question that says, what's the solution to this system? Then you'll do a point and then it'll say, is this solution independent? And you will have to say yes. Is this solution consistent? You will say yes or no, and it'll say yes.
So what does independent mean in this case?
In this case, independent means that it is basically just meeting and has one solution and doesn't depend on anything else. It's just, it's not dependent
But
on
if they're
anything.
parallel lines, are they independent or no?
They would be considered, you'll find out in the next video, they will be inconsistent. You have so many questions. Hold up, why is
The
this
system
all
of equations.
up in here? Hold on, I'm just gonna go back to this. These videos are on your Canvas, okay? I'm on period 7 right now. Yep. You can watch them anytime you want.
Anytime, anywhere.
So you want to know how to solve the system of equations. Well, let's take this system of equations and solve it by graphing. So in step number 1, let's take each equation and put it into slope-intercept form. In other words, let's solve each equation for y. So taking our first equation and solving it for y,
He's gonna do it
we get
again.
that y equals 2x minus 2.
Skipped a bunch of steps.
Now let's look
Okay.
at our second equation. When we solve that, we get that 2y equals 4x minus 8. Dividing both sides by 2, we get that
Did one
y
of those
equals
steps.
2x minus 4. Great. Now we've solved both of our equations for y and put them into slope-intercept form. In step number 2, let's graph our equations.
Because she divided by
Draw our
2.
coordinate
Why was
plane.
being multiplied by 2? So she divided by 2 to get rid of
And
the
then
2.
let's start by grabbing
And
our
get on the
first
other
one.
side.
Y equals 2x minus 2. We have a y-intercept of negative 2, and then we have a slope of 2, or 2 over 1. So we go up 2, right 1, up 2, right 1. And we draw our line. Now let's graph our second line. Y equals 2x minus 4. We have a y-intercept of negative 4, and again we have a slope of 2. So we go up 2, right 1, up 2, right 1, and we draw our line. Now we have both of our lines drawn on our graph. The last thing we need to do to find our solution is to find the point of intersection between the two lines on our graph. So looking at our two lines, at what point do they intersect?
No solution.
Hey, these two lines don't intersect one another. If we look, we see that the lines are parallel to one another, and parallel lines never intersect. So that means we will never find a point of intersection between these two lines. And since there's no point of intersection, that means that there's no solution. We will never find an ordered pair that when we plug them into both of these equations will give us a true statement in both cases. So our system has no solution. In other words, the system is called inconsistent. Now let's look back for a minute at the two lines that we started with. Y equals 2x minus 2 and y equals 2x minus
This is
4.
really important.
If we look, we see that they have the same slope, a slope of 2, but they have different y-intercepts. So lines that have the same slope and different y-intercepts are parallel to one another. So we could have seen just by looking at the lines before we graphed them that these two lines were parallel, and thus they had no intersection, and so the system had no solution.
Okay, so that's what I was talking about when I said that this lesson is super easy because we already know how to graph lines. We already know how to put things in slope-intercept form. We already know what parallel lines look like.
This is nothing like the readiness test.
Well, there's a lot more of this topic that we're gonna get into.
But it was pretty easy.
Guys, I lost my train of thought because you were interrupting me.
It was easy because of the graphing.
We learned about how to graph parallel lines. We also learned what parallel lines look like before you even graph them, because we see that the slopes are the same, but what's different?
Y-intercept.
The y-intercepts. So, can you determine if there's a solution or no solution just by looking at the equations?
Yes.
Absolutely. I've got a joke for you that I made up, and I think you're gonna like it. Okay, ready? Uh-oh. Why do parallel lines argue all the time?
Because there was
Yeah.
no solution.
Because they can never find a solution. Very good. My last class did not get that joke. Good job. Okay. It's a good one, right? You should tell your parents. And they're gonna be like, what do you mean? You're gonna be like, oh, you don't get it. You don't understand. Algebra. All right. So I'm just gonna go through a couple of, actually I'm gonna wait till you guys quiet down. We're losing learning time. I'm gonna go through a couple of examples that are gonna look so much like what we just saw on the video. And this is really funny. And I'll show you in a second. Not funny, haha, funny, like what the heck. Okay, so this whole lesson is about solving solutions by graphing. Really, the only time you're gonna need to graph it is if your lines do intersect. If you look at your lines in slope-intercept form and you say, okay, definitely not the same slope, so they're not parallel, and they're not the same line, so they're not the same equation, so they're not gonna have infinitely many solutions. Now we know we have to graph this to find a solution, at least in this lesson. In the future lessons, we're gonna solve systems by doing things that doesn't involve graphing, and you're gonna like those so much better,
Thank you.
I think. And the great part is like when you get a test and it says solve this system by graphing, you can be like, okay, that's cute, but I actually know a different way to solve this, and you can solve it any way you want. There are 3 ways to solve. You can choose. But for today, we're learning about graphing. What do we use first from this equation to graph? The y-intercept. Yeah, you guys can just shout it out so we don't run out of time. Our y-intercept is -4. This is a little strange. This is what I was saying. It's not funny, haha. It's funny, weird. This y-axis gets cut off at -2. So how am I supposed to graph that -4? I'll just extend the line and go a 1 and a 2. And that would be our y-intercept. And then -2 is our slope. So what would that look like when I plot that?
So like oh, it would go like that way. It would go to the left.
Okay, somebody give it to me in rise and run. Yeah.
Down to right one.
Very good. Down 2 over 1. But it's correct, but watch what happens. Down 2 over 1. I'm going so far away that it's not really working, even though it's correct. So down 2 over 1 is not working. What can we change our slope to that's totally equal to this, but will move us in a different direction?
Up to left 1.
Very good. Up to left 1, right? I can move the negative because if a fraction is negative, it doesn't matter if the numerator is negative and the denominator is positive, or vice versa. Still the same. Up to the left 1. Watch this. Up to the left 1. Up to the left 1, 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 and so on and so forth. So this slope, the way that it's written, wasn't very helpful to me, so I just moved the negative to the denominator and went the complete opposite way. Okay, so the next equation here, we have a +6 y-intercept, which, yay, it actually has a +6 on the graph, so that's our y-intercept. The slope is giving it to us in a decimal, which that's not very helpful for rise over run, is it?
No.
How should we write this for rise over run?
1 over 2.
1 over 2 would be great. Now watch what happens. Up 1 over 2, up 1 over 2. I'm going farther away again. What should I do?
-1 over 2.
Nope,
Okay.
2 over 1.
nope,
-2 over 1.
nope,
Oh, no way.
1 over 2.
nope. What?
What?
Who said that?
I said -2 over -1.
Yes, you little genius. Wait, what?
No, -1.
-1 over
Okay, what was it? She was so close, I got excited. You're right, okay. 2 brains are better than 1. -1 over -2. It doesn't look like the same number, does it? Is it the same value?
Yeah.
Yes. This is a positive fraction, and so is this. Negative over negative is positive. So I can rewrite 1 over 2 to be -1 over -2. Can we not have that extra noise? That means I can take this and I can go down 1 and to the left 2. Down 1 to the left 2. Down 1 and to the left 2. Oh! I've already hit my point of intersection. That's my solution. Let's see what point that is. 1, 2, 3, 4. So that's -4 and 1, 2, 3, 4, +4. -4, +4 is my solution. Should we stop there or should we check
Keep
to
going.
make sure? Now, I'm pretty confident that that's what it is, but let's check because on your tests and homework, you're gonna wanna pluggy back in your x value and your y value to your original equations of the lines, just to make sure. So if my y is 4, I'm gonna plug a 4 in here, I'm gonna plug a -4 in for my x. This is the first equation, this is this one right over here. Multiply -2 times -4, you get a positive 8. Subtract 4, you get 4. Does that equal 4?
Yeah.
Yay, it worked. Same thing. Equation over here. Why are we plugging in the exact same x and y?
Because it's
the answer.
negative form or positive form.
Because they both have the same one.
Right, because we're testing to make sure that that's a solution for each line. We're testing to make sure that it will be true when I plug it into both of them. That's the only way that it is a solution. If it's a solution for one of them and not the other, it's not a solution of the system. Okay, so -4 and +4 goes on the y, -4 for the x, multiply, what's half of -4? -2, plus 6 would be +4, does that equal 4?
Yeah.
Yes.
But wait, why isn't one negative?
What?
Why isn't one of them negative?
Why isn't what
Like
negative?
one of the fours.
There is.
This is a -4.
Yeah, I'm saying on that.
There is both. The one in the parentheses.
This is our x value on the ordered pair. So the -4 goes in for the x. All right, are we good?
I guess so.
So what we're gonna do is just A together. Oh, look, they're in perfect slope intercept form. Let's go ahead and graph them, okay? We are, spoiler alert, these are going to intersect because look, different slopes, so they automatically are definitely not the same line, and they're not parallel either. Different slopes, different intercepts, they're gonna intersect somewhere. Let's find out where. I'm gonna pick on people. I've got my first equation here. Angus, what do I graph first? How do I plot my first point using this equation? The y equals half x minus 2. What do I use from that equation so that I can just plot my first point? Well, let me just ask you, if you tried to graph this equation, how would you know where to put your first point? What about the equation gives you a hint of where to plot my first point?
It tells you the y equals like what's there, so you have to use your
You wanna phone a friend on this one? Okay, Faye.
if you would start by -2.
Right, we would grab our y-intercept. That's always how we start. I don't know what was just happening there, but that's always how we start. We grab our y-intercept, which is -2, so we plot a point on the y. Boom, that's our first point. Then, Angus, could you tell me what we use next to plot our second point?
I get to with the I get to here with the thing.
I can't hear you.
You can't see it.
Yeah. So
Oh, you can't see the board?
Yeah, because of the
Okay, can you
light.
stand up and walk over just a little bit? It says y equals 1/2 x minus 2. What's the next thing that we grab to help us plot our next point?
you have to grab the 1/2.
Yes, that's our
Slope.
slope. Good, you can sit, thank you. We're grabbing our 1/2 because that's our slope. That's gonna tell us how many to go up and how many to go over. I'm gonna go up 1, over 2, up 1, over 2. And since I don't really know where the intersection is gonna be, I might wanna go backwards also. What would that look like?
That one.
Huh?
That one.
Oh,
Yeah,
it'd be negative, right?
yep, both negatives. Down 1 to the left 2. Down 1 to the left 2. Now I've got a lot of points. I'm gonna go ahead and hope that the intersection is one of those points. If not, I can keep going with that slope. Next one here, Lily, what do I pull from this equation to graph my very first point on this line? Yes, -7. 2, 3, 4, 5, 6, 7. That's my y-intercept. And then let's see who else I want to pick on. Let's see, Charlotte. What do I grab? What else do I grab from my equation to plot my next point?
Come on, which one are you on?
This one, the one that we've been on this
Oh yeah.
Yeah.
Did you start it? I'm just so confused.
Oh shoot, were you not paying attention?
No, I was zoned out.
Zoned out, okay, love the honesty. Who wasn't zoned out that would like to help us? Faith, you've been amazing, but I'm gonna give somebody a chance, Brianna.
After that, we do the slope.
The slope, which is
3.
3. Give me that 3 in a rise over run.
3 over 1.
3 over 1. So we're going to take our y-intercept, excuse me. We're going to go up 3, 1, 2, 3, and to the right 1. Oh, I can already see it's going to have a match. 1, 2, 3, and over 1. There's my point of intersection.
Why is it like?
Because I can't draw. That's why. Okay. I put a little star. Thanks for pointing it out, Jocelyn. Okay. So here's my point of intersection. I need quiet, please. And we're just going to identify that ordered pair. What's the ordered pair?
2 over negative 1.
Yeah.
Like 2
Positive 2. Well, not over, yeah, but positive 2. Negative 1 is my solution. Should we stop there?
Nope.
Or should we check?
Check.
Let's check. I'm going to plug in my y value, negative 1 over here. I'm going to do 1/2 times my x, which is 2. I'm going to put that in parentheses. I'm going to put the 2 over 1, stay in fraction form, and then subtract 2. Cancel, cancel. What's my answer to this?
1.
1 minus 2 is?
1.
Negative 1.
Negative 1. Negative 1 equals negative 1. Check. All right, let's do this guy. I'm going to plug my negative 1 in for my y. I'm just doing this one down here. And then my 3 times my x, which is my 2, minus 7. What's 3 times 2? What's 3 times 2? 6 minus 7 is?
1.
Negative 1 equals negative 1. Checky check. We did it. No big deal. It's kind of awesome.
No one answered. Oh, I was writing it
It's
down.
okay.
That's
Nobody
why I
pays
didn't
attention to me.
answer.
I'll just stand here.
I pay attention. Like, I
You
got
okay?
3
You're on
pages.
fire today.
Yep.
I actually have 2 pieces of candy, and you are getting. Sorry. The Twizzlers do not like. They do not very
You don't go weak.
Yeah, yeah, yeah.
Miss, like, did you steal that from your kids like you said you were?
I'm on camera right now. What if my kids watch this video? Okay. Actually, no. It was donated to me by another
Exposing
learner.
mom.
Yeah. I've already posted in my neighborhood Facebook page to say if anybody has extra candy from Halloween, give it my way so I can
Bro,
replenish.
I have a whole like pillow case. Like,
If you don't want it, bring it in.
nah.
No, you want it. I know if you want it, obviously I'm not gonna ask for
I
it.
have to eat like a load of it.
Oh, Miss, my parents.
I'll
my
steal
parents
that.
have to hide.
Yeah, if anybody has extra, just bring it in. I'll replenish. Hello, I only have a few minutes left and I have 2 more problems to do. But I've got good news. Now we're on to the type of systems that are either parallel or exactly the same. So we can solve them without graphing. It's like solve it by graphing without actually solving by graphing. It's like, tell me, you get what I'm saying? Like solve it by graphing without actually solving by graphing.
Yes, please.
We can do that by just identifying some similarities in the equation. Now, these equations do not look the same at all.
They are.
But they are. They put them on separate graphs just to, I don't know, show that they are exactly the same line. I'm going to rearrange them in slope-intercept form to prove that they are the same line. And then I don't even need to graph them. I would know the solution. Okay? I'm going to, all I have to do for this one is what? Just switch them. I'm going to take my negative 3x here and my positive 5 over here. Now it's in slope-intercept form. I'm going to do a magic trick where I'm going to turn this crazy thing into this. You want to see? 15x plus 5y equals 25. Watch my magic trick.
Divide by
No. Subtract 15x from both sides. Minus 15x here. Then I have 5y equals. Don't try to actually subtract these numbers. I've got a negative 15x and a 25.
minus 15x.
But how do I want to write it?
Negative 15x plus 25.
Yes, I want to choose my x term first, then my positive 25. Still doesn't look like it. My magic trick's not over. Divide by 5 on both sides every term.
What?
Cancel. Y equals Hello?
Negative 5x.
Yeah, divide by 5 on
Negative
Plus
5x.
5.
negative 3x
Plus
plus
5.
plus 5. Magic. Same exact equation
Just flip it.
as this one. If it's the same equation, it's the same line. Therefore, it has infinitely many solutions. I've got one more, and then I'm going to let you guys pack up. If you try to pack up before, I'll keep you after, and I won't give you a pass. So get in trouble. I know, doesn't it just fly when we're having so much
This
fun?
one's so hard.
Please stop talking, or I'll make the whole class stay. That would not be nice, right? What is the solution of each system of equations? Oh, this is another system of equations. Use a graph to explain your answer. Okay. These do not look alike, so we don't know yet. Pretend this isn't here, okay? We're gonna rearrange these. I'm gonna take my negative 2x and I'm gonna move it. I'm gonna add it here to cancel it out, and I'm gonna add it here. But I'm gonna switchy, so I have y equals 2x plus 6. Then I'm gonna do a little magic over here. I'm gonna add 4x to get rid of it on this side. Add 4x over here. I've got 2y equals 4x plus 8. Divide by 2 on both sides. Every term, 2's cancel out. I get y equals
2x
2x
plus 4.
plus 4. Is it the same equation?
No.
No, that was a trick question. What's the same
The
about
y
it?
The slope.
What's the same?
Slope.
And what's different?
The y-intercept.
What does that mean?
Yeah, it's parallel.
How many solutions?
None.
None. That's it. You guys can wrap up.